Thank you. Thank you all for having me here, and welcome to my talk titled A New Network in Cold War Mathematics, How Individuals Shaped the CFSG Network circa 1950 to 1980. The following analysis originated as part of the CFSG historicization project. The 1950s were chosen as the starting point because that's when the network truly began to form, and the 1980 was chosen as the endpoint, as around this time the project was initially declared as finished by Aschbacher and Gorenstein, as we just heard from Rebecca. My research aimed to show how a part of this vast network was formed and maintained, as well as how it grew and what we can learn from this regarding mathematics during the Cold War. For the next 20 minutes, I want to present to you my research and how it fits into the larger historicization project. First of all, I want to talk about the foundations regarding my research. Next, I want to present my method and the data I used for the analysis. Then I talk about the results of this network analysis. And finally, I want to very briefly go over the implications my research may pose for collaboration in mathematics. To start, there are a few aspects that motivated me to get invested into the topic of the CFSG, despite me having no actual mathematical knowledge. I still don't know how I ended up here, but I'm going to try my best. First of all, did the CFSG project exemplify for the first time a large-scale collaboration in mathematics involving mathematicians worldwide. This collaboration helped divide the enormous task of classifying finite simple groups, enabling systematic and stable progress over decades. Then, unlike many Cold War era projects, due to its theoretical nature, the classification project was not driven by military agendas, but was still able to secure financial support from both civilian and military institutions, which to me, as a novice in the field, sounded odd. On this basis, the project serves as an early example of extended teamwork in mathematics, practice that later became standard. And finally, from the point of view of historic institutionalism, understanding the CFSG network offers insights into the social and institutional structures that shape scientific collaboration. This brings me to my research objectives of the analysis I wanted to conduct. The main question I wanted to answer is, how was the CFSG network formed and sustained from 1959 to 1980? To be able to answer this question and demonstrate what made the project special, I formulated 3 research objectives. My primary objective was to examine the theory that individuals, rather than institutions, played the central role in organizing and maintaining the network. When we think of collaboration, we may picture some guiding and organizing entity, and from a precursory glance, the project didn't seem to be steered by any governing institution. Then the second objective, demonstrate that Daniel Gorenstein acted as an informal coordinator, ensuring the project's continuity. Gorenstein never assumed any official position or title in the project. However, other popular figures in the project called him the de facto CEO, as we already have heard. I wanted to verify or falsify this notion with quantifiable data, which hadn't been done before. This was more of a general gist of the participants in the project. And finally, the tertiary objective, proof that unofficial communication is vital for formation and sustain of the network. I will explain what I mean with unofficial communication. In short, it's the type of communication that's unfortunately not documented that well. As I already hinted at, the primary and secondary objectives in particular are more or less accepted in the mathematical community, yet there was no empirical study or quantifiable evidence to actually support these claims. The tertiary objective, meanwhile, aimed by hopefully being verified to be applicable to other large-scale scientific collaboration as well. Next, I want to talk about the method I chose for the analysis, as well as the data it was based on. The method I chose is the historical network analysis. So to put briefly, the historical network analysis is an adaptation of the social network analysis. The HNA enables the visualization of historical networks and helps with uncovering hidden relationship and enhancing understanding across historical subdisciplines. Thus, the historical network analysis applies social network analysis methods to historical contexts, focusing on past instead of present social relations and interactions. An HNA can be conducted from a micro level, being focused on a few individuals, a macro level, so analyzing society as a whole, or meso level, which means bridging both of these concepts. Networks can be categorized by relationship strength, meaning the characteristics of relationships divided into strong and weak ties. Relationship symmetry, meaning whether the flow of information is equal or one-directional. And complexity, so whether the network shows all possible connections or only focuses on some of them. Here I need to expand on relationship strength, as its meaning for a network is rather counterintuitive. Strong ties require high maintenance and are usually deep, like year-long friendships, relationships, etc. Weak ties, on the other hand, are cursorily and low maintenance, like being distant colleagues or acquaintances, only meeting ever so often. However, these weak ties are usually better for networks, as they are, as I said, of lower maintenance, so more of them can be had at once, and they allow for better connections outside one's own bubble. All networks are categorized into being either egocentric, meaning centered on one or a few individuals, or non-egocentric, so showing all relationships equally, with further distinctions for human-only, so social or mixed actor, so socio-material networks, which also display non-human actors like institutions, for example. To be viable, the historical network analysis requires converting historical sources into quantifiable data. Of course, this poses many challenges. For example, the accuracy of historical sources, the iterative nature of hypothesis testing, and the requirement of contextual knowledge can all hinder the HNA and need to be addressed. Speaking of data, let's get to the meat of the CFSG project, the publications. Gathering and sorting through the publications with the fitting MSSC code led to the following. From ZB Math, we found 1,150 papers and books, which were supplemented by 400 additional publications from Math Scinet after sorting out duplicates, of course. This led to 1,550 papers by 406 authors. However, only 38 of these authors had more than 10 publications on the topic under their belt, and while this is a lot of very useful data for the historicization project, for the preliminary network analysis I wanted to attempt, these numbers had to be slimmed down. However, first, here is a map showing the location of employment of the 406 mathematicians when publishing the articles and books that we were able to pinpoint as of now. As can be seen, the US is in the lead regarding publications, followed by the USSR. Due to software limitations, this is geographically shown as Russia, but this 315 publications also includes the Soviet states at the time. This map shows that the CFSG project truly was a global project and present on all continents. So, coming back to the database, it included not only papers and books, but also institutional funding records, all of which I call official communication. Furthermore, we included conference proceedings, letters, interviews, obituaries, and mentorship records. These I call unofficial or informal communication, as they are either not recorded in publicly available sources or not really connected to the research itself. Conferences here can count as both. Talks are normally official publications of results. However, meetups between or after these talks can be unofficial means of exchange. Finally, publications from the self-historicization that followed the project were also used as a means to discern connections between mathematicians. As I hinted at before, 1,550 papers by over 400 authors, additionally to the sources I just mentioned, is too much data to form a network analysis with meaningful results in the short time and frame I had. So I limited my analysis to 20 mathematicians I call the key players. The selection of 20 key players was based on publication output, geographical ties to the US, and sustained contributions to the project. This selection allowed for a manageable network reconstruction while still representing the larger collaboration. The choice of key players aimed at first to align with both quantitative and qualitative considerations. However, at the stage the historicization project was at the time, and given my non-existent mathematical expertise, so my inability to qualitatively prove the output, a quantitative approach was easier to achieve. The list you can see here includes some names of people you have just heard from Rebecca, for example, Solomon, Mason, Janko, Thompson, Aschbacher, Gorenstein, Lyons, and Smith. As Rebecca stated, these people had a significant influence on the project, so this hopefully gives some credibility to this quantitative approach. After identifying the key players, the basis for the following analysis of the network of the CFSG project consisted of 277 publications, so papers and books, from 1959 to 1980 in total. Some of them were written by multiple key players in co-authorships, so the numbers in the second column add up to more than 277. Split that up. 14 conferences from 1959 to 1979, multiple letter exchanges, and 6 interviews. 4 of these interviews are from the 80s, so shortly after the conclusion of the project and the beginning of the self-historization, as we already heard, and the other 2 are from last year. Of course, there are potential biases in this selection, on which I comment after showing you the results, but they are, after consideration, a good or at least good enough basis for a representative analysis of the CFSG network. So, coming to the results of the analysis. To make the network somewhat comprehensible, I split it up by analyzing the different sources separately. There is not enough time to talk about every network iteration, but I can elaborate on a few of them. And to demonstrate what I mean by the need of making the network more comprehensible, this is the complete network, taking all the data in consideration for only 20 individuals. To make it somewhat more understanding, the key players are colored orange, institutions are green, and conferences blue. And even though I split the network up in its constituent parts, this network map is already pretty informative. It consists of 99 nodes, so people and places, including the 20 key players, and it is egocentric. All of these connections are only from the 20 key players and only counted once, meaning connections between, for example, 2 non-key players, which might have been there and most likely were there, are still completely disregarded. Thus, with 633 connections, this means that there were 31 connections on average to other people and institutions for every key player. To summarize and abridge the results of the analysis before focusing on some noteworthy details, the CFSG network was initially shaped through official channels, including published papers, university affiliations, and conferences. Especially conferences played a significant role in connecting mathematicians, facilitating idea exchange, and structuring the collaboration. The network was multiplex, with participants connected through multiple channels such as co-authorships, joint conferences attendance, and even personal friendships. Also, the best connected individuals were crucial for the self-historization, which we'll come to after my talk. So, one aspect of the network that needs to be further highlighted is its growth. The CFSG network expanded significantly from the 1960s, late 1960s to the 1970s, with increasing complexity and participant numbers. Early contributions were dominated by a few key figures, while later stages saw a broader distribution of collaboration. Strong ties within the network persisted, while weak ties, such as occasional conference interactions, facilitated its expansion. The later network was denser and more interconnected, reflecting its growing scope. It is noteworthy, however, that mathematicians did not leave the project. Most of those who started in the project stayed with it, meaning the early network is still fully present in the later network. There are no leaving connections. Then I want to show the differences between the networks of the official and unofficial communication, as I defined them. The analysis and comparison of these 2 networks showed the official communication and collaboration reached farther, allowing for more connections on average per key player. The unofficial network, in contrast, had fewer connections, which were more often reiterated and, let's say, cherished. An example of these strong relations were generations within the project. Mathematicians having doctoral students on the case, who then in turn had students on their own in the project. This shows that to form, maintain, and expand a network, both official and unofficial communication is needed, and both strong and weak ties have their merits, thus somewhat proving the tertiary objective of my analysis. I now want to expand on the rather minor role of institutions in the project, beginning with the exchange facilitated by them. The analysis showed that the CFSG project was primarily driven by individuals rather than institutions, institutional involvement playing a supportive but non-central role. Conferences played a more significant role than universities in sustaining information flow and project coordination, allowing for individual exchange of this information. This meant that while the CFSG project received institutional funding, of course, it avoided bureaucratic restrictions, making it an example of a self-organized scientific network. This is reinforced by the previous notion that no contributors really left the project. Regarding funding, I need to address funding on the research, as money is something that is essential for scientific conduct. The NSF and the AMS were responsible for most of the funding of the research done by the 20 key players. There is also funding from military organizations, the Air Force and the Navy, even though the classification of finite simple groups offered little to no direct military applications. The reasons for that we already somewhat discussed yesterday, and it will also be addressed in the larger historicization project. As this was an international project, funding from foreign sources, of course, also found their way to US mathematicians. To conclude this chapter on institutions, the analysis managed to prove the primary research objective, identifying that individuals played a greater role in maintaining and expanding the network than institutions. The analysis showed that one of these individuals, if not the individual for the project, was Daniel Gorenstein. Gorenstein played a central role in coordinating the CFSG project, despite the absence of a formal governing institution. This earned him the title of de facto CEO by his colleagues, and this claim can now be backed by the quantitative analysis verifying the secondary research objective. He helped systemize the classification effort, breaking it down into manageable subproblems, and his extensive connections with nearly all key contributors positioned him as the primary organizer of the collaboration. Gorenstein initiated efforts to document the classification process as well, making the work accessible to future mathematicians, which we will, I'm sure, also hear more about later. Because of that, his books and papers shaped the narrative of the project. In the analysis, this is proven by Gorenstein being central in every iteration of the network and having the most connections by a large margin. You can see him everywhere being central, and yeah. Except for the early networks, so 1959 to 1969, where he simply wasn't that active yet. Gorenstein maintained active communication with contributors through letters and conferences, and he also played a major role in integrating younger mathematicians into the network, ensuring its continuity. Of course, this analysis is far from perfect or even complete. There are limitations and challenges yet to be overcome. First comes the issue of incomplete and asymmetrical data. Many relationships in the CFSG network were informal or unofficial, so letters, mentorships, conference conversations weren't always recorded, making them difficult to document comprehensively. Because of that, there are most certainly gaps in the data collected and analyzed. Also, the historical record favors formal collaborations, potentially underrepresenting key interpersonal connections. Secondly, there may be an over-reliance on quantitative metrics. The network analysis relied heavily on publication data, which may not accurately reflect the importance of individual contributions. Some key figures like Richard Brower, Walter Fate, or Jonathan Alperin had significant influence but published fewer papers, making their role harder to quantify. You can see Brower being near the bottom there of this table, and Alperin and Fate are not even on the list, despite their significance in the project. Wait, I'm too fast. Another quantitative problem is the importance of references and citations. Books were also only counted as one publication. However, they can be distinguished by number of references, implicating different results when analyzed qualitatively, of course. Then there's the difficulty in distinguishing strong and weak ties. Network analysis as a method can struggle to differentiate the impact of the differing form of relationships on the project's success. Finally, there's also, of course, a potential bias in source selection. The study focused primarily on mathematicians in the US, limiting insights into the network's full international scope. Institutional records and self-historization efforts by Gorenstein and others may introduce narrative biases as well. So, to conclude my talk, I want to briefly address implications my research may hint at. Unlike traditional mathematics in the centuries before, where individual researchers work more or less in isolation, the CFSG project required coordination across multiple mathematicians and institutions. This aligns with what we've talked about yesterday, the gradual shift towards collaboration in the last century, and expands it on an even larger scale. The CFSG project thus demonstrated that large-scale decentralized collaboration in mathematics is feasible and effective. Next, the project showed the merits of decentralized organization versus institutional control. As its network functioned without centralized control, this challenges the assumption that major scientific projects require strong institutional oversight and suggests that informal leadership can be just as effective. And finally, the analysis of the network showed that long-term stability is possible through informal communication. The CFSG network not only persisted but flourished for more than 2 decades, largely due to a mix of strong ties and weak ties. This balance ensured both stability and adaptability, providing a model for future long-term mathematical collaboration. To end, I want to break down what, in my opinion, can be learned by analyzing the network of the CFSG project. The findings of the analysis suggest that both documenting and understanding informal networks when studying collaboration in mathematics and in science in general is vital for understanding both mathematics and its history. With that, I want to thank you for listening. Here are some of the sources used, and I'm looking forward to questions and remarks. Thank you.
I was looking for questions. I just want to add one thing. This is the results, or part of the results, of Lukas' master thesis. So this is not the start of the project, but it's a report in a way, just to put it in perspective. So the floor is Adler.
So I have a question about your choice of key players. You said that you looked at US-based key players, but I was asking myself, why did you put Conway there? Because Conway only had a permanent position in Cambridge, and he became a professor in the US only in 1985 when he stopped working on group theory.
Yeah, but to my understanding, he still had a significant influence there and was referenced there. So yeah, I said they were only US-based, but in my research, I also used people who had significant impact in the US research. So Conway wasn't stationed in the US, but he had still had influence there. So this, as I said, this was at the start. There was a very quantitative approach, and I was just looking at who was publishing there without having any or much actual insights into the larger project or any understanding about what they even talked about, to be honest. And so this may have been a little bit blurry, but I decided to put Conway there. I decided to put Thompson, for example, also there.
Enacting his CEOship, as it were? Is he kind of chopping up little problems and saying, okay, you and you and you are going to do these, or are people kind of organically starting to work on these? How is that dynamic?
Yeah, he was more or less the distributor. I think, as I said, there was no official position, but at some point people just decided that Gorenstein and his activeness in the project was so reliable that he was basically responsible for gathering new results, new questions that popped up in the project, and distributing them to other researchers. So he was more or less the coordinator.
So are people, if you're a kind of up-and-coming group theorist, you write him and say, can you give me a problem? Or
that's
no,
really.
It's much less structured and organized as it appears now. One of the reasons why he became so prominent was that he was not only doing work on the classification project, but that at some point he came up with a plan how a proof could eventually be organized, based on earlier work by John Thompson. And when he announced this program, lots of people thought this was crazy, but it was the only plan and program they had. And then they decided to follow it to some degree. And yes, it's true that sometimes he would take a chunk and talk to someone and say, do you think you can do that? And in conferences, for example, at conferences, they would present a result and say, and this fits in with Danny's program there. But it was not as clearly organized and somehow openly known, like, yes, you should write him a letter and ask him for homework. This is not how it works. It's much less informal than that, and we're still working on understanding this better, because it's really, really difficult to find reliable evidence. There's a lot of people remembering something, or we find little hints here and there, but it's difficult to really pin it down.
If I may add on to that, in the interviews that I will be talking about later, it's mentioned quite often that there was a conference and Gorenstein was there and people presented something and he made a remark such as, well, someone should do that, and then someone would pick that up and do it. So it was very informal from what we have in these interviews. Yeah. So Norbert and
thank you very much for this talk. I don't know whether this question is asked at the right moment, but I appreciate very much what you did. But if I understand correctly, this network analysis is about publications only. On the other hand, the word that we hear more and more often, and that you also mentioned in your presentation, is conferences. And since we are talking about a time period when conferences become as common as they are now over the time, has the project reflected about somehow mapping in a qualitative and quantitative way, conferences that are more or less specialized, or conferences where an essential part relates to this project, and how to map this out in a somewhat similar fashion?
You can start and I can pick up.
So first of all, the analysis started by identifying the key players with publications, but then also added in conferences and sources from conferences. And we've already started mapping these out. We're still gathering more conference data. Of course, we have specialized conferences on the topic of the CFSG, but there are also, for example, ICMs where multiple key players attended and talked about the finance simple groups.
So that is high on our to-do list. We discussed that just last week. And it's one of the points where the external funding comes in, especially also the Air Force, sponsoring these conferences in order to produce mathematicians that can be.
Yes, and the NSA. And then we also have the long programs that were very impactful, which is why I would challenge that with the advantages of the decentralized approach. I wonder what would have happened if we had just put everyone together in some place like a retreat for 2 years.
Okay, you and then June.
I want to come back to Rebecca's comment about Gorenstein having some sort of initial plan. Obviously, things didn't work out according to that plan, or did they?
Oh, they did to a surprising extent, actually, if we look at the first generation proof, except for a few little things that were missing, like construction or uniqueness proof for some individual group. But there was one major gap. So I'm not sure how I should say this. A slightly offensive way to say it would be one person didn't finish the homework. A bit more friendly, maybe. This was one of the technically most difficult pieces of the whole thing.
The quasi-thin problem.
The quasi-thin problem, yes. And the person who, it takes courage to even raise your hand and say, I'm going to do that. So hats off to Geoff Mason for doing that. And then it was not finished. It's not clear to me yet. I will ask him tomorrow. It's not clear to me yet to what extent this was clear to him himself, what was still missing and how severe this would be and how it could be finished. And as we saw, it took a decade for this to become really apparent, and then new people had to raise their hand. And I understand the later part of this fairly well now, because I've talked to Aschbacher and Smith about it, but I want to understand the other side of the story and the beginning, and that starts, of course, with Geoff Mason. But if we take this out of the picture, the gap, this big gap, and then one or two little things, then it is actually surprising how much of Gorenstein's strategy worked when we look at the first generation proof.
Could I just ask Rebecca too, was it a specific conference or event that took place where he set that out, and then did it quite quickly become a consensus for the people working on this?
Some of the details are still missing for me. I'm working on piecing this together better, but we can at least state a year, and we have written documentation of this program and of lots of technical details. And what people tell me from that time is that quite a few thought, and I quote literally, this is a pipe dream, not gonna happen. But within a relatively short time, lots of people changed their view on this, in particular because Gorenstein had a lot of evidence that some of these strategies had already worked in the past and had produced partial classification results. And he was very transparent most of the time about where the difficulties were, where there were gaps, and where his strategy was already really clear and worked out in much detail. So all of those who were knowledgeable enough could really follow this plan, and then they could have an informed discussion about where this is maybe too sketchy and where this actually already works. That's how I would
So I
answer this.
think
And I'm
the
sorry for
year-
answering.
No, no, go
The
ahead.
year we can pin to that is 1972, I think, in Chicago, when he presented his program, and people thought, well, we just don't believe it. So, last question goes to June.
Actually, I was originally going to ask what Norbert asked, but I'm going to ask something now a bit different. I was just wondering about the publications and to what extent whether specific journals were very much involved, editors of journals, refereeing processes, you know, how that all played in. Was that a silly question?
Oh, yeah, well, I think the AMS played a significant role in publishing it, and there were also the communicators for the papers were also often part of the project. For example, Walter Fate or Bertram Huppert were also, most of the time, essential in presenting the publications to papers, etc. To journals. Sorry, to journals. Yeah.
But we have not yet looked into some kind of distribution, which journals, I mean, the Journal of Algebra for a while was key. I think that it's in various places that you find the publications.
I guess it's too recent to be able to access things like referee reports and things, which would be.
Sometimes we have things because people found it somewhere and donated it to us.
Yeah.
Yeah, sometimes we're lucky, but it's really difficult to look at this systematically for exactly the reason that you just mentioned.
Yeah, it would be kind of interesting to.
Yes. I want to see all these reports for the grants, for the papers, for the submissions, for conferences. If I could, of course. I want to look at them.
Thank you.
Isn't it true that the notices of the AMS though devoted through various editors considerable pages to giving the overviews?
Yes.
And we studied this extensively, and this will also have an influence. This is also how we found a lot of funding sources that were surprising.
Okay, let's thank Lukas again.